Okay, so hello and welcome to this video tutorial for E411, Statics and Dynamics of Simple Mechanisms. So we have this problem here. The members of a truss are connected to the gusset plate if the forces are concurrent at point 0, point 0. Determine the magnitudes of forces F and T for equilibrium. Take theta to be 90 degrees. So I'm just going to go ahead and show how I'd tackle this problem. First of all, I'd probably think about the geometry of the problem. We have this kind of 3-4-5 triangle idea going on here, which we can use for resolving this force vertically and horizontally. We can say that the horizontal component of this F force here is 4/5 F, and that the vertical component is 3/5 F. But we don't have any kind of idea for this T force here. So how we might kind of understand this? Let's have an attempt at drawing a 90-degree angle. So it says here that theta is 90 degrees, so we can take this as 90 degrees. If we imagine we have this 3-4-5 triangle here, and we have, and this is our force F, and this is, I apologize for my handwriting. This is our force F, and this is our force T. They're acting at 90 degrees to each other. What I want you to do is essentially understand, picture this 3-4-5 triangle rotating 90 degrees clockwise. And if we picture this 3-4-5 triangle rotating 90 degrees clockwise, it might end up looking like this, where all of a sudden the vertical is now 4 and the horizontal is now 3, right? The hypotenuse remains 5. So this looks just like this. And this helps us understand everything we need to know now, really, about the geometry of this problem. Okay, so we understand that this system is in equilibrium, or that we're looking for the values of F and T where the system is in equilibrium. This means that we have this idea that the sum of the forces in the horizontal direction can be taken as 0, and the sum of the forces in the vertical direction can also be taken as 0. Let's start by resolving horizontally then. So we can say that 0 is equal to 4/5 F. If you're unfamiliar with this idea, I'll explain it briefly here. So we have this 3-4-5 triangle that's kind of aligned with this force F. Understand that the hypotenuse here is 5, and that the horizontal component here is 4. So what we can essentially say then is that the magnitude of the horizontal component, let's say the horizontal component here, can be taken as 4/5 of the magnitude of the force. So the horizontal component of force F can be taken as 4/5 F, where F is the magnitude of the overall magnitude of the force. Okay, let's continue with that idea then. We can say, I should have said minus 4/5. Sorry, minus 4/5. The reason I'm saying that is because the horizontal component is acting to the left, and we typically take left as the negative direction on the horizontal plane. And now I'm going to add the 3/5 T. So that's this is me resolving horizontally, right? Now, is this solvable? No, it's not solvable. The reason it's not solvable is because I have two unknowns. I have F and I have T. Okay, so since it's not solvable on its own, let's go ahead and resolve vertically now. So we've got 0 taken from this idea here. The vertical is also 0. We can say that minus 3/5 F minus 4/5 T plus 9 is all equal to 0, right? The minus 3/5 T is this vertical component here. The minus 4/5 T is from here. The reason that they're negative is because these components are acting down, and we typically take down to be the negative direction in the vertical plane. And the 9, of course, comes from this vertical force here of 9 kilonewtons in magnitude. So, is this problem solvable now? Well, yes, we have two unknowns, F and T, but we also have two independent equations. And if we have as many independent equations as we do unknowns, then the problem is typically solvable. So, you know what, let's make some more room here. Now, when I look at this problem, there are several ways of approaching it. When I look at this problem, I'd probably look at it and think, I'm going to have a go at using the substitution method here. And if you're unfamiliar with the substitution method, I would suggest learning more on simultaneous equations. So let's just separate that out. I'm going to rearrange equation 1. I'm going to label that equation 1 and equation 2. I'm going to rearrange equation 1, so I've got 4/5 F is equal to 3/5 T. Apologies for my handwriting. And I'm going to multiply both sides by 5/4, which gives me F is equal to 15/20 T, which is equal to 3/4 T. If you're not familiar with what I did there, I'd suggest working on your algebraic rearranging. Okay, so I'm going to label this equation 1 now. So I have F in terms of T. I can then say I'm going to move these F, this 3/5 F and 4/5 T term to the left-hand side kind of implicitly here. And I'm going to say that 3/5 of 3/4 T. So I've substituted this 3/4 T in for my F here, plus 4/5 T equals 9. Okay, so 9/20 T plus, I'm going to change the denominator here to 20, so that would be 16/20 T equals 9. Okay, so 25/20. Oh, I'm running out of room. Let's move this down a bit. 25/20 T equals 9. Therefore, let's multiply both sides by 20/25, which is 180 25ths is equal to T is equal to, where's my calculator gone? (180/25). 7.2, lovely. So that's the magnitude of T. And conveniently, I've got F in terms of T here, so I can say that, therefore, F equals 3/4. I'm just going to move my face if I can. Yeah, wonderful. 3/4 of 7.2, which is equal to 5.4. I'm also going to include my units here, so 5.4 newtons and 7.2 newtons. I've underlined them, and you know what, I'm going to encircle them as well, because that's good practice.